Hello viewers. Today we're diving back into the world of AI programming. We're going to focus on creating agents using the Agent Development Kit. As you know, I've tested out several frameworks on my channel, but I really appreciate ADK for its simplicity. The barrier to entry is extremely low. You can start coding almost immediately, with very little setup. Let's move on to practice as usual. First, the documentation. You can easily find it on the project's website. The Build Agents tab offers an excellent introduction to agent programming, no matter which language supported by the ADK you choose to use. You'll find descriptions of a lot of topics in the menu, covering both basic and advanced stuff. By the way, version 2.0 was released in May 2026. Alright, let's dive into the hands-on part. We'll start by setting up the environment. I prefer using Linux because it is the most natural choice. However, if you're on a Mac or Windows, don't worry. The steps will be quite similar. I'm running Debian 13 on my system. First, I'm going to update the package list from the sources because we need to install a few things. Python 3, since that's the language we'll be using. Pip as the package manager, and the venv for creating a virtual environment. As you can see, I already have it installed. That's why I can create a virtual environment in the ADK directory. I'm changing folder to the ADK. Now I can activate the environment. Please notice that the prompt has changed, indicating the environment is now active. This means anything I install with pip will go into this environment. So, I can go ahead and install Google ADK. As you can see, the installation takes a while because we have quite a few dependencies here. And installed. Now we can create our first agent using the command ADK create agent name. Choosing a large language model doesn't really matter at this point, because I'm going to switch it soon anyway. The command has created a folder with several files for us. Let's take a look at what's inside. Here we've got several folders and files related to the virtual environment, but our new project is in the Storyteller folder. 3 files have been created. init.py, which makes the agent a package and includes the import of the agent.py file. The agent.py file itself is the definition of our new agent. We also have a .env file that contains environment variables, and this is exactly where, in the first step, I need to define my API key. This is not the only option, but for simplicity, we will use this approach for now. The easiest and best way to generate an API key for Gemini is by visiting AIStudioGoogle.com. Look for the Get API Keys tab there. If you want more details, I've explained the process in one of my previous videos. I already have a key, and it will magically be placed in my .env file. Just remember, it's a secret and shouldn't be shared with anyone. Let's move on to the agent's code. As you can see, it's not particularly complicated. First, I'll choose a model. I like Gemini Flashlight, since I don't need anything more here. It's a very efficient yet inexpensive language model. The second thing I need to correct is the agent's description. It's not that important here, but I'll describe it briefly. My first agent will be responsible for storytelling as an AI wizard. The instruction is much more important. This defines behavior of our agent driven by the large language model. Usually, this instruction is an important part of working on an agent, but our case is very simple. And believe it or not, that's all. In less than 5 minutes, we've prepared our first agent. Does it seem impossible to you? Yeah, it might feel like something's missing here, but we'll revisit it later. So it's time to start the agent. I can easily do this using the command ADK run agent name. The agent started up properly, and now I can communicate with it. I asked for a story. As you can see, the response came quite quickly because it's a very fast model. The subject of the story comes from the system prompt. that is from the agent's instructions. I know this agent is pretty simple and doesn't use any tools, but we'll dive into that in future episodes, step by step. For now, I just wanted to introduce something really basic. By the way, I could respond to the agent right now, since we're in a classic React loop. It's this exact loop that lets us have an interactive conversation with the agent. I'm bringing it up now because we'll come back to it in just a bit. However, I'm going to break the execution now and demonstrate another ADK feature. ADK Web lets you start agents through a web interface. I'm not mentioning the agent's name here because I can choose it directly in the interface. Typically, you don't have to include the host option, but I'm using it because my setup is a bit more complex. By following the instructions, I can access the agent interface on my localhost IP and port 8000. The ADK web interface is very intuitive, yet also rich in options that allow you to monitor the agent's actions. I asked the agent for a story, and look, we already got a response. Like I mentioned, Gemini Flashlight is super fast. Apart from chatting with the agent, I can also check out its execution trace. This lets me see exactly how long each part of its operation takes. While this is a pretty simple case, having this info can be incredibly useful for optimizing more complex agents. Let's see what else we have in this interface. We can create a new session, which suggests that session management is available. We can also select one of the existing ones. You know this functionality from most AI interfaces. Next, we can preview the structure of the current agent. In this case, it is extremely simple and contains only one element, the root agent. Next up is agent selection. As you might remember, we launched ADK Web without specifying an agent name. This interface lets you select an agent from any subfolder. On the left, you can see some technical info about the current event, which is interaction step with the agent. Then there is a visual presentation what was triggered. Next, there's a handy feature that lets you see exactly what was sent to the LLM in this step, and also what came back. As you can see, this is the story prepared by an agent, wrapped in a structure, exactly like it was sent by the large language model's API. The last thing I want to show you is the call summary, which gives you details about the tokens used. This directly impacts the operating costs of the agent. Right now, with a cheap model and this number of tokens, the cost is basically negligible. But in the future, you'll likely want to keep an eye on it. But let's return to our agent's code, because it was suspiciously simple and short, wasn't it? Take a look at this program. What exactly is happening here? We've got one import and the definition of an agent, but there's no code being executed directly. To demonstrate this, I'll go ahead and run the file. Let's go to the agent folder and run Python. As expected, nothing happened. It's still a fully functional agent, and you can always run it through ADK command, or even deploy it to Google Cloud, and it'll work just fine. But let's consider what needs to be done to get it running as a Python program. In fact, there are two things that the ADK command gives us out of the box. The first one is a runner that implements the agent loop, that is React loop, which I mentioned earlier. We also have session handling. In the case of a local agent, it will be an in-memory session. And if we properly deploy the agent to the Cloud-to-Agent engine, it might be a managed session service. But of course, this is only the default behavior. We can always define these two elements explicitly, and then we have full control over the agent's behavior, regardless of where it is run. Let's try to prepare such an implementation. I will need async I/O because the program will use asynchronous methods. I also need load.env because I will load environment variables from the .env file. The ADK command did this implicitly, but here I need an explicit call. Next, I will define the asynchronous main function, which I want to be executed when the program starts. And I'm also adding its call right away. Now, let's figure out our next steps. First off, I'm going to set up my session service. Since my agent will only be working locally, we'll go with an in-memory session service. As you can see, this constructor is not recognized, so it's clear that an import is missing. This is of course an integral part of ADK, so I can easily import it. Now everything is fine. We already have the session service imported, so we can create a session. The create session function requires at least 2 parameters to be specified. The first one is the name of our application, and the second is the user ID. The user doesn't really matter here, because I plan to invoke my agent only locally and won't be managing users. So we already have the session created, and as I said, we should have at least 2 elements. The second one is the runner, which is essentially the engine of our agent. To define the runner, I also need one import. Runner also requires input parameters. First of all, I have to pass the previously defined session mechanism that it will use. Of course, a reference to our agent is required, which is the root agent. And additionally, the application name must be defined. And that's all. Now we need to prepare a conversation with the agent. I won't be handling prompt input. We'll make a hard-coded ask for a story. But just having the text isn't enough. A message needs to be constructed based on that, so the LLM recognizes the source of the request, that it's coming from the user. As you can see, it's not particularly complicated, but we're missing the import of types. I'll add it right away. And I think that's all the imports we need. Everything is defined, and we can move on to the actual invocation of the runner, using the runAsync method. Look at how we define the runner. It has information about the session service and the agent. However, it lacks info about our session. That's why we provide the session ID, the username, and additionally the conversation history. In our case, just one message. The runner's operation should give us the agent's response, so let's get ready to print it out. Because we are calling the runner's asynchronous method runAsync, we won't get the response in a single step. Instead, we will have a stream that must also be handled asynchronously. So we need to iterate over the objects we receive, check what's inside, and put everything together into one whole. If the current chunk is text, we simply print it out, and that's all. Contrary to appearances, it's not very complicated. Let's also print a new line character at the end for better readability. And that's all. As you can see, setting up a basic runner isn't too tricky. And sure, you might have noticed that we aren't implementing an agent loop here. We're just sending one query to the agent and print a response out. But that's precisely why we create our own runner. To get the custom behavior we want. That's the flexibility. Okay, let's go through our code step by step once more, to make sure we understand everything correctly. At the beginning, we have the import section, because we needed in-memory session service, runner, and types. Then we explicitly load the environment variables from the .env file, since we need our API key for Gemini. After that, we have the agent definition, which we used even when we didn't use the custom runner. Next, we have the main function, where we first initialize the session service object and then create a session using the hard-coded user ID. Next, we create an instance of runner using the defined session service for our root agent and obviously the storyteller application. The command we will send to the agent is tell me a story, but of course it needs to be wrapped in an object to create a message. Now we have the most important part of our agent from an operational point of view. Runner.runAsync ties everything together and sends an asynchronous request to the large language model. The only thing left is to receive responses from the runner in the form of events and display them on the screen. And that's absolutely everything. We can now try to run the program. I'm launching the agent exactly the same way I tried to do it before. And we have an answer. There is a story and the agent doesn't ask me for a response, just ends the program. Everything according to plan. All right. If you're still not fully grasping the last example with the manually defined session service and runner, don't worry about it. After the next episodes, it might become clearer. For now, I wanted you to understand what you get out of the box thanks to the ADK command. I want to show you that creating agents can actually be even easier than what we saw earlier. As you may have noticed, when we define a basic agent, we don't use much Python programming. So, someone had the brilliant idea to simplify it further by using a language called YAML instead of Python syntax. YAML is a standardized and simple document structure. If you're not familiar with YAML, don't worry. You'll get to see it in action shortly. I'm creating a new agent, just like before, using ADK Create. However, this time I'll add the parameter type equals config. The name of our agent is Storyteller2. Just like in the previous case, I'm asked about the model I want to use. And just like there, it doesn't matter at all, because we'll be changing it. Let's now take a look at the files that have been generated in the Storyteller2 folder. This time, our root agent is not located in the agent.py file, but in root agent YAML. Here we have a very simple structure, a list in format, field, value. When you look at it, in terms of content, it's very similar to what we had at the beginning in the Python file. So let's define our own content for the storyteller. The model is still Gemini Flashlight. The description will be exactly the same as for our first agent, because we want to replicate its behavior. The instructions will also be exactly the same as at the beginning. By the way, I would like to remind you that usually the instructions should be much more detailed, but of course here we are trying to present the simplest possible case. And that should be enough to start the agent. I won't be showing you the text interface anymore, but trust me, it works the same way. We'll jump right into the ADK Web, where you can also see how to select between agents. You might remember where we were choosing the agent earlier. Yes, now we have both versions of Storyteller available. I'm choosing the new one. Now, as usual, I'm asking about a story. As usual, we received the response very quickly, so we can say that the agent based on the YAML definition also works without any problems, and it is consistent with the first version of Storyteller. The key takeaway is that both agents are fully functional and can be seamlessly deployed to a cloud runtime without any problems. I won't go into detail about that in today's episode, but I want to highlight that the ADK command does come with these options. Out of the box, you can deploy the agent to 3 different runtimes: Agent Engine, which is currently Gemini Enterprise Platform, Cloud Run, and GKE. In my opinion, Agent Engine is the most interesting of the options. Let's see what the parameters of this command are. At first, the number of parameters might seem overwhelming, but it's actually quite simple. At the very top, you have 2 basic patterns. The first uses an API key, and the second is based on a GCP project. If you have environment variables related to the GCP project setup, deployment really comes down to a very simple command: ADK, deploy, agent engine, agent name. And that's it. But as I said, we won't be diving into that today. I think it's worth a separate episode if there's interest. Speaking of interest, I'm wondering if you'd find it helpful if we put together a full series on ADK, diving into more complex subjects. We could cover deployment, using ADK with models from other vendors, advanced agent-related topics like memory and evaluation. I think it could be really interesting. Let me know what you think in the comments. And for now, thank you very much for your attention and for watching this video to the end. May your agents always be easy to build and very helpful. See you next time.